Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to start learning how to divide polynomials, y'all. And the monomial operations of exponents, we're done with those. But all of those are still valid. We need to know how to work with all of those. So before I start teaching you how to divide polynomials, I'm going to give you a very brief but very accurate review of the laws of exponents. Number one, multiplication. When I multiply the same base, y'all, a to the m times a to the n, it equals a to the m plus n. Basically, when you multiply the same base, you keep the base and add the exponents. Number two, when I raise a power to a power, if I have a to the m raised to the n, I distribute the n to the m. So it'd be a to the m times n. If I have ab raised to the n, I distribute the outside exponent to every exponent inside the parentheses. So that would be a to the n times b to the n. If I have a divided by b raised to the n power, I distribute that outside exponent to the exponents inside of the parentheses. So when I raise a power to a power, whether it's a single term or the product of several variables and or numbers, any monomial, I keep the base or bases and multiply the exponent. I'm going to distribute that outside exponent to everything inside of the parentheses. Division of monomials. When I divide the same base, I keep the base and subtract the exponent. So a to the m divided by a to the n equals a to the m minus n. Remember that we taught a much easier way by just canceling. Okay, remember that. If I have a to the 7th over a squared, that's easy. That's a to the 5th. Where a lot of people mess up is when you have a squared over a to the 7th, they also say a to the 5th. That's where the canceling method comes in a little bit easier. You have 2 a's up here, take 2 away from here, so I'm left with 5 a's down in the denominator. So always remember the canceling. You're doing the same thing, you're subtracting, it's just a little bit quicker. The negative exponents. Whenever I have a negative exponent, okay, if I just take its reciprocal, I change the sign of the exponent. So if I have a to the negative n over 1, I bring that a to the negative 1 to the negative n to the denominator, it becomes a to the positive n. If I have 1 over a to the negative n in the denominator, and I bring it up to the numerator, I make that integer exponent a positive. And if I have a over b to the negative n, I can flip the inside of the parentheses. I can make it b over a, and I change the sign of the exponent. I do not change the sign of what's inside the parentheses. You could distribute the negative. You could do this. You could make it a to the negative n over b to the negative n, which equals b to the n over a to the n when you make them positive. Or, like I said, you can simply flip them right from the beginning and then change the sign of the exponent. Choose which way you want to use, but choose one way, gentlemen. Choose it, learn it, live it, and love it, and master it. Become great at it. Do it that way. Become good at that way, whichever way you want to do it. But rest assured, if you are going to do it this method, please do not change the sign inside. What do I mean? Let's say I have x to the negative 3 over y squared. This is what messes up a lot of people. To the negative 4 power. Me, how I like to do it, I flip this. And then I change the sign of this. But when I flip the inside of the parentheses, I do not change the signs. I do not. I change the sign of the outside exponent. Now I distribute, that's y to the 8th over x to the negative 12th, Now I move that x to the negative 12th up, so it'd be y to the 8th, x to the positive 12th. If you want to just go ahead and distribute the negative 4th first, you can. You're going to get the same answer, I promise. Choose one method, though, and stick to it, is my opinion. So again, what does this mean? That when you make a reciprocal, you change the sign on the exponent. And it should be of the exponent, not on the exponent. You change the sign of the exponent. Okay, so these are the rules. Yes, sir. Okay, that's why I gave you this example, sir. When you're using this method, you're changing the sign of this exponent, not what's inside of the parentheses. That's why I said if you don't like that method, don't use that method. You change the sign of the exponent when you move them normally, okay? But when you have this particular situation, you don't. Look. Let me give you another example. If I have x to the negative 3, sure, that's 1 over x to the negative 3. If I have y to the negative 7th over x to the negative 4th, that equals x to the 4th over x to the 7th. Simple enough, right? Yes, sir. I'm sorry, positive 3. Simple enough, right? Everyone with me there? Okay, now, when I put this into parentheses, it's a whole different ball of wax. Now, I have two options here. The regular way would be to distribute the negative 3, which becomes x to the 9th, over b to the negative 12th, which equals x to the 9th over b to the 12th. That's a nice, perfectly fine way to do it. And everyone can do it that way. There's no worries. There's no problems. I have no issues with it. However, there is another way to do it, which is what I'm articulating here. When it's in parentheses, very big, only when it's in parentheses, I can flip the inside of the parentheses without changing the signs, and instead I change the sign of the exponent outside of the parentheses, which gives me b to the 12th over x to the negative 9th, which gives me b to the 12th, x to the 9th, which gives me the same exact answer. Does that make sense, sir? Do you see why I didn't change the sign inside of the parentheses now? Thank you for your honesty, sir. Does that make sense, everybody? Thank you, sir. It takes guts to ask. I appreciate it. Anything else on this, gentlemen? 0 exponents, anything to the 0 power is 1. Please be careful. If I have 6x to the 0 is affecting the x. This will equal 6. If I have parentheses, 6x to the 0 is affecting the 6 and the x. That would equal 1. Please be careful of that. Okay. All right. Does that make sense? Thank you. Okay. May I continue, boys? Thank you. Okay. Now, in order to properly divide a polynomial by a monomial, remember the following rule, guys. When I have a polynomial, a plus b, divided by c, the bottom denominator gets divided to every single term in the numerator. So a plus b over c really means a over c plus b over c. So that's what I'm going to use regardless of how complicated we get. For example, 12x to the 4th plus 24x cubed plus 4x squared divided by 4x squared. Yes, I could do this in my head. Whoop-de-doo for me. Who cares? Practice the long way until you've mastered it. What does the long way mean? It means this, guys. 12x to the fourth is being divided by 4x squared, plus 24x cubed is being divided by 4x squared, plus 4x squared is being divided by 4x squared. And this is going to equal 12 divided by 4 is 3. I got 2x's here, 4 here. I'm left with x squared. Plus 24 divided by 4 is 6. X cubed divided by x squared is x. Plus 4x squared divided by 4x squared is equal to 1. And it's that simple. Looks scary, but it's very simple. Yes, sir. If I have a negative power, I do it like normal. Let's say it was 12x to the negative 8th divided by 4x squared. Okay, so this would be 3 x to the negative 10th, which would equal 3 over x to the positive 10th. And that would be your answer for that particular term. Don't let negatives scare you. Calculate them as normal and then turn them into positives, sir. So for this guy, I know it's tempting to do it in your head. Trust me, I want to do it in my head too, but I want to teach you. Teaching you is better than just showing you an answer. So 8a squared b cubed divided by 2a squared b squared minus 6a squared b over 2a squared b squared plus 5ab squared over 2a squared b squared. Okay. 8 divided by 2 is 4. A squared divided by a squared is 1. B cubed divided by b is b. Done. 6 divided by 2 is 3. A squared divided by a squared is 1. B divided by b squared, I've got a b down in the denominator. Plus 5 over 2, I cannot simplify that, so that's 5 halves. I've got an a in the numerator, a squared in the denominator, so I get rid of 1a in the numerator, 1a in the denominator. I'm left with 1a in the denominator. B squared divided by b squared, they cancel, and that is my answer. So sometimes you will have answers with variables in the denominator, and that's okay. That's part of the way it goes. Does that make sense, gentlemen? Bless you. Yes, sir. No, I had 1a here, and I had a squared here. So I got rid of 1a here, I get rid of 1a here, and I'm left with 1a at the bottom. Thank you, sir. Yes, sir. No, because it's not 3b, it's 3 over b, sir. No, you cannot put 4b minus 3 plus 5 over 2ab. Absolutely not. Because b is only to the 3 here. 2a is only to the 5 here. We're going to learn how to do that, but what would have to happen is I need a common denominator. Now I would need to find a common denominator of 2ab and then convert all of these fractions. So great question. We're going to get there, but you're not there yet. So no, absolutely not. These each have their own individual denominators. It's like saying 1/2 plus 2/3. Oh, that can be 1 plus 2 over 6. That's basically what you're telling me. That makes no sense, right? Exactly. Because you need common denominators. So no, that would be your answer. Okay. Now, when dividing a polynomial by a binomial, remember basic division, guys, and follow the same procedures. Let me show you some basic division. Let's go back in time. If I have 579 divided by 16, 16 goes on the outside, 579 goes on the inside. 16 goes into 57 how many times? Okay, 3 times, 3 times is going to be 48. See how I subtracted the product, right? I subtracted 3 times 16 from 57, right? Drop down the 9. Borrow, that's a 9. How many times does 16 go into 99? 6 would be 96, correct? So this goes 6 times. That's 96. And then I have a remainder of 3, right? So this remainder of 3 is 3 over the original divisor of 16, right? That's basic, right, guys? Same exact procedure. Does that make sense? Okay. So let me show you how this works. X squared plus 10x plus 21 divided by x plus 7. You put your x plus 7 on the outside. You put your x squared plus 10x plus 21 on the inside. You're going to only work with this outside x. Ignore everything else about the outside polynomial. You're only working with this x. And then you're going to ask this question over and over. How many times does x go into x squared? If you don't know off the top of your head, show yourself. Okay, what's x squared divided by x? Whoever said twice, that's wrong. Think about it. X squared divided by x equals x. That's why don't guess, show yourself. So how many times does x go into x squared? It goes in x times. Subtract the product. X times x is x squared. X times 7 is 7x. Distribute the negative. So this becomes negative, this becomes negative. This first term must cancel. 10x minus 7x is 3x plus 21. Now we go back to the drawing board. How many times does x go into 3x? Show yourself. 3x divided by x equals 3. So x goes into 3x, positive 3 times. Subtract the product. 3 times x is 3x. 3 times 7 is 21. Distribute the negative. That becomes negative. That becomes negative. They cancel. There's no remainder. My answer is x plus 3. Okay? It's very simple. But you just have to take your time, follow procedure. Yes, sir. Then if the divisor has several terms, then you have to multiply that number to all the terms. It works always, but you always work with the first term, with the leading coefficient, with the leading term. For example, I have 2x minus 1 into 6x squared plus 9x minus 10. How many times does 2x go into 6x squared? Don't guess. 6x squared divided by 2x equals 3x. Very good. So this goes in 3x times. Subtract the product. When the bell rings, don't go anywhere. 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. Distribute this negative. So that becomes positive, this becomes negative, that becomes positive. This first term has to cancel. If it does not, all due respect, you messed up. You're left with 12x minus 10. How many times does 2x go into 12x? Positive 6 times. Subtract the product. What's 6 times 2x? 12x. 6 times negative 1 is negative 6. Distribute this negative. That becomes negative. That becomes positive. These cancel. If that does not happen, all due respect, you messed up. Negative 10 plus 6 is 4. Negative. Can x go into a number by itself? That's my remainder, which I write as plus negative 4 over 2x minus 1. This is something you're going to have to watch a couple times, guys. Okay? You're going to have to watch it a few times. Okay? Yes, sir? My answer is right here. Is 3x plus 6 plus negative 4 over 2x minus 1. Yes, sir. Guys, please. Yes, sir. If there was a 2xy, I don't understand what that means. If it was 2xy minus 1, then there would be combinations so that you have x's and y's. Same thing. That wouldn't exist. You're giving me scenarios that don't exist. Yes, sir. There is no 6x, sir. How many times does 2x go into 12x? 12x, that's why I said don't guess, show yourself. So that would equal 6. Okay? I'm going to do one more together with you guys. Okay? I know, lunch, I know. I miss lunch all the time for you guys. So x squared goes on the outside. On the inside, I've got 5x to the 5th. Okay, I got to go in order, standard form. So, plus, do I have a x to the 4th here? So 0x to the 4th, because I don't have one. Plus 12x cubed. Plus 2x squared. Minus 9x. Plus 8. Don't be afraid. Just go step by step. Yes, sir. It's 0 because do I have an x to the 4th here, my man? So I put 0 so I could go in sequential order of the exponents. Okay? Thank you. Okay, so how many times does x squared go into 5x to the 5th? Please don't guess. 5x to the 5th divided by x squared equals 5x cubed. So 5x cubed. Subtract the product. 5x cubed times 5x squared is 5x to the 5th. Plus 15x to the 3rd. Distribute the negative. That becomes negative. That becomes negative. That cancels. I don't need my 0x to the 4th. I don't use it with that, so I don't need it. But what's 12x plus minus 15x cubed? Negative 3x cubed. Drop down the 2x squared. How many times does x squared go into negative 3x cubed? Negative 3x cubed divided by x squared. How many times? Negative 3x. So it goes in negative 3x times. Subtract the product. Negative 3x times x squared is negative 3x cubed. Negative 3x times 3 is negative 9x. You with me here? Okay. Distribute the negative. This cancels. I got 2x squared and a 9x. Can I add those two together? So I've got 2x squared, but what's negative 9x plus 9x? That cancels. So I drop down my 8 instead. How many times does x squared go into 2x squared? No, it doesn't go in one time. We're guessing 2x squared divided by x squared equals 2. So it goes in twice. So 2 times x squared, subtract the product. That's 2x squared. 2 times 3 is 6. Distribute the negative. And I'm left with 2, which is my remainder. So I have plus a remainder of 2 over x squared plus 3. I suggest you guys take your time and watch this video. And I'm going to continue here I'm going to continue during my lunch. You guys may leave, and I'm going to show you another thing called synthetic division. Please be quiet when you leave so I can continue recording. Thank you very much, and have a great day. Bye-bye. Have a great day. Okay, now, synthetic division. Synthetic division is a lot easier, but it's only, you can only use it when the leading coefficient of the divisor is 1. So remember to always write in standard form and fill in missing values with 0. So what am I talking about? I have x to the fourth minus 2x cubed plus x squared plus x minus 1 divided by x minus 1. The first thing you want to do is find the root. How do you find the root? You set the denominator, which is x minus 1, equal to 0. So if I set x minus 1 equal to 0, x equals 1, and that's what my root is. So I put a 1 here. And now I put all the coefficients of the numerators in order, and if I'm missing any exponents, I place a 0 there. So in order, the coefficient of x to the fourth is 1. Then I have a coefficient of negative 2 for x cubed. I have a coefficient of 1 for x squared, a coefficient of 1 for x, and then I have my negative 1. Now, here's the beauty of synthetic division. Drop down the first number, which is 1. Now, 1 times 1 is 1. Negative 2 minus 1, or negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. 1 minus 1 is 0. 1 times 0 is 0. 1 plus 0 is 1. 1 times 1 is 1. Negative 1 plus 1 is 0. Now, this is the part that will make your life super easy. You started with x to the fourth. You're going to rewrite your answers starting with 1 less exponent. So if I started with x to the fourth, I'm going to start with x cubed. And these are my coefficients. So I have 1x cubed minus 1x squared plus 0x plus 1. That's my last one. That's my constant. And there's no remainder. Now I clean this answer up. It's x cubed minus x squared plus 1. Because 0 times x is 0. Let's do another one. First off, I want to write this in standard form. So it's x squared minus 16x plus 70 over x minus 9. My root is 9. My coefficients are 1, negative 16, and 70. Drop down the 1. 9 times 1 is 9. Negative 16 plus 9 is negative 7. 9 times negative 7 is negative 63 with a remainder of 7. I started with an x squared, so I'm rewriting my answer now with 1 less exponent. So I have 1x minus 7. This is my remainder plus 7 over x minus 9. And that is my answer. And last but not least, my root is 2. My coefficients in order. 2 for the x cubed. 0 for x squared because it's missing. Negative 5 for the x and negative 7 for the constant. I drop down my 2. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. Negative 5 plus 8 is 3. 2 times 3 is 6. Negative 7 plus 6 is negative 1. I started with a cube. I'm going to rewrite my answer with 1 less exponent. So I've got 2x squared plus 4x plus 3 plus my remainder of negative 1 over x minus 2. This is where you have to be real careful. Yes, sir?
What if the x has a coefficient at the bottom end?
I don't understand what you mean by that. If there's a coefficient here in front of the x, then you cannot use synthetic division. That's why I said at the beginning of synthetic division, you can use when the leading coefficient of the divisor is 1. Thank you, though, so much, sir, for caring and for asking. Thank you very much. Hope you had a great day and a good lesson. Hope you learned a lot. Bye-bye.